This is the AQA Function Skills Level 2 non-calculator paper, in other words paper 1, for June 2021. You're allowed 30 minutes to complete this paper. Okay, so let's start. Question 1 gives us 10 numbers. They ask for the mode, and the mode is the one with more, and you notice you have 1, 1, you have 2 2s, 1 3, 2 6s, 3 7s and 1 9, which means there's more 7s than anything else, so that's your mode. Question 2. Question 2 is a order of operation, so you do your brackets first, then you do your powers, then you will do your your multiplication and division, and finally you do your adding and subtracting. So you notice you have a power here, so when you work that one out, that will be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So we've done the power. There was no brackets, so that's why we didn't do any brackets, because there were none. But we've done the power, so we move on to doing multiplication division, and we find there's a multiplication here, which says it's going to be 5 times the answer from 2 cubed, which is 8. And 5 times 8 is 40. So we've done the multiplication, we will now do the addition, and so we had 12 plus 40, 12 plus 10 is 50, plus 2 will be 52. So the answer here was 52, but I write the answer in the answer box. 2 marks, because there are several steps to show. Question 3 is a grid question. And question 3, you can see they give us a grid with the y-axis, the x-axis, and they tell us we have 3 vertices. Vertices are corners of a rectangle, and you can see we have the corners of a rectangle. They're asking us to work out the corners of the 4th vertex. Now, the top of the rectangle will be the same as the bottom of the rectangle, so it's going to be there. So that's the one we need to find out. Now that is 4 along, and it's going down 1. Okay, so if you notice it's here at -1, and if you notice it's here for 4. So the coordinates are 4 and -1. Let's move on to question 4. And when we have question 4, we have here a decimal, take away another decimal. When you do that, you just need to make sure that the decimals are in order, and you also are starting with the first one. So we have 0.826, and we're taking away 0. Notice I've aligned my decimal points 47. Since there's nothing here, I'm going to put 0. And that's quite nice, because 6 take away nothing is going to be 6. 2 take away 7 we can't do, so we're going to have to borrow. So I'll borrow from one in front, so that becomes a 7. That's a 12. 12 take away 7 will leave us with 5. We check, because 7 plus another 5 is 12, and that's what we had. Now we have a 7 here because we borrowed from it, so we're left with 7. 7 take away 4 is 3. Dot, dot, dot. 0 take away 0 is 0. So the answer for this is going to be 0.356. Right, we're now on to putting some numbers in order. In question 5, we have a list of numbers, and they want them to put in order, and it says starting with the largest. So this is where you have to remember that on number line, you'd have 0, and the numbers get bigger the more you go this way, and they get smaller the more you go that way. In other words, the more negative it is, the smaller it is, and the bigger on this side it gets bigger. And that's kind of a bit obvious. So we want the largest one, so we're looking for the largest number there, and you can see the largest number is 12, so we're going to start with 12. Okay, and then counting backwards, the next biggest number you can see is 4. The next biggest number is 2. So now we are here, so we would want something that's smaller. So is there a -1? No. Is there a -2? No. A -3, a -4. Oh, so this next one we're going to come across is a -5 or a -5. And then you get your negative 7, and then finally you'd have your negative 15, and that's the smallest number because it's the one that's more to the left on the number line. Question 6 is a calculation to do with fractions, and in this case you notice the denominators are not the same, and we would like the denominators to be the same. But you spot that they've been very nice and they've given us 4 and it's 8. So what I could do is, if I double that whole fraction, I will have a 6 over 8. Here I had a 7 over 8, and now we have the denominators the same. We're taking away. Since the denominators are the same, we can keep the denominator, and we can say 7 take away 6 is 1. So the answer for this is going to be 1/8. Let's move on to question 7. And question 7 is section B. So we've reached section B, those slightly longer questions. And they tell us we're talking about personal finance. Anna is looking at her finances, her net monthly income, so this is how much comes in from her jobs. And they also show us her monthly spending, so this is how much she spends. And here we have all the information about everything she spends. And they tell us that she saves the rest of her monthly income. So whatever she spent, then whatever's left she saves. What fraction of her net monthly income does she save? And give your answer in the simplest form. So first we're going to have to add all of those together to find out how much she spends in total. Now they've been quite nice because we could actually do it here to save space. 0 plus 5 plus 0 plus 5 plus 0 will be 10. Carry 1. And then we have 1 plus 7 is 8. 8 plus 19, sorry, 8 plus 9 is going to be 17. 18. 18 plus another 8 would be 26. 26 plus another 9 is going to be 35. So I write the 5 and I carry 3. 3 plus 4 is 7. 8, 9, 10, 11, 12. There's nothing here, so I'm not going to add anything. 12, 13, 14, 15. She spends 1,550. Okay? But we want to find out how much she saves, and that's what's rest. In other words, what's left over. So if she has an income of 1,750 and she's spending 1,550, we can see how much she saves because she basically is a subtraction of what's left over. 7 take away 5 is 2. So she's basically saving £200 every month. Okay, but that was not the question. The question was not how much does she save. The question is what fraction of her monthly income does she save. So if we write this as a fraction, we save, or she saves 200, and her monthly income was 1,750. So now we can do a bit of cancelling to see what happens, because I want it in its simplest form. So you notice this ends in 0 and this ends in 0, so we could basically divide by 10 on top and bottom, or cancel the 0. So now we're left with a 20 and 175. And again, you can see that this here ends in a 0, this ends in a 5, which means they're both on the 5 times tables. So 5s will fit into 20 and 5s will fit into 175. So how many 5s fit into 20? Well, we know that 20 is 4 lots of 5. And this might be a little bit harder, so you might need to do a little calculation somewhere else. So I might do a little division just to check how many 5s are in there. Does 5 fit into 1? No. Carry 1. Does 5 fit into 17? Yes, it does. 3 lots of 5 is 15, but we have 17, 15, 16, 17, so we have 2, a remainder of 2. How many 5s in 25? 5. So we now know that 175 is going to be 35 times 5. And because there's a 5 on the top and a 5 on the bottom, I can cancel, and I'm going to be left with a 4 on top and a 35 on the bottom. And now there's nothing else I can do, because 4 I could only divide by 2, but I can't divide that one by 2 and get a whole number. So that is our final answer, 4 out of 35. And that's 4 marks. Let's look at part B. And part B has a scatter graph. They're telling us that Anna wants to know approximately how much gas she's using in the winter. Here's the information for 18 days. 16 of the points are shown on scatter graph, which means that 2 points are missing, and you can see down here we have 2 points. The diagram shows the maximum daily temperature and the amount of gas used every day. Maximum daily temperature on the bottom axis and how much gas in kilowatt hours she uses on the vertical axis. The table shows data for the other 2 days. Use the scatter diagram with the extra points, we're going to have to plot those, to estimate the number of gas or the amount of gas she uses when the temperature is 5 degrees. You must show your workings on the diagram and give you units. So first things first is to plot 8 and 32. So when its temperature is 8, the usage will be 32. And now we need to work out what's on this side. So let's see, is it jumping up in ones? No, because 1, 2, 3, 4, 5 won't work. 2, 4, 6, 8, 10, so it's jumping up in 2s. So if I want to do 32, I go to 30, and it would be the next box up. You might want to use a ruler to help your eyes see what's happening and follow the line, but in my case I can see the line going along here, so 32 until it hits the 8, and so that is the extra point we're going to plot there. That's 32 and 8, so we've done that point. We now need to do the next one, which is 3 and 55. So when it's 3, it needs to be 55, and 55 is going to be in the middle of 50 and 60. Okay, if there's 5 boxes, it means it's going to be 2 boxes and a little bit. So when I get to this one, I'm going to get to 50, 52, 54, and 55 will be in the middle there. Okay, so we plotted it. Good. We now need to use the graph to find out how much she uses when it's 5 degrees Celsius, and we can't do that without plotting a line of best fit. So you're going to have to try and get a line that goes through the middle of as many of those points as possible. If you have a line here, it wouldn't be good because there's no points at the bottom. If you have a line there, there's no points at the top, and if you do something like that, there's points over here at the bottom and points. So you see that you basically want to go through as many of those points as possible. And at this point, in this case, you're just going to have to go for what kind of feels or looks right to you, and you might be getting a slightly different line to somebody else. Okay, but that's looking quite good. I'm just going to put that one there, and I'm going to draw my line of best fit. Okay, you might want to do it with a pencil to start with and then put it in after with a pen, but we've got our line of best fit. So now we're going to use that to answer the question. So we look for 5 degrees. Here's 5 degrees. So with a ruler, I'm just going to draw a line that goes up to 5 until it touches my line that I drew. Okay, there we are. And when it touches that line, we are now going to draw a line that goes horizontally until it gets to where we are. Okay, and you can see that that basically is pointing there. So in my case, my answer would be 42, 44, but your answer might be slightly different because you must use your line of best fit, and if your line is just slightly different, you might get a slightly different answer. So in my case, I get 44, but remember they want units, so the units are kilowatts, so we're going to kilowatts, and there we are, the answer and the units, 5 marks. That's a nice question to do for 5 marks. We're now on to part C, which is actually also the last part of this paper. And they're telling us that she wants to reduce her water bill. The amount she uses, she pays for the amount she uses, so that makes sense. She reads this advice and it tells her that if you turn off the tap while you're brushing your teeth, you will save 6,000 litres of water in a year. They also tell us that the tap water costs her £1.427 every time she uses 1 cubic metre. They also tell us that 1 cubic metre is the same as 1,000 litres. Anna says, if I follow the advice, I will save more than 70 pence per month. So we're first going to find out how much she saves, and then we're going to have to compare it with her statement to see if she's correct or not. Okay, so let's find out how much she will actually save. So we know that she will save 6,000 litres of water. So we know that she will save 6,000 litres of water. Every litre is 1 cubic metre, and I want to find out how many cubic metres this is. So how many thousands are in there? So if I divide that by 1,000, I find that there are 6 cubic metres that she will save of water in 1 year. Now 1 cubic metre costs that much, but she has 6 of those, so she has 1.427 times by 6. So when we work that one out, we're going to say 6 times 7, so 6 times 7 is going to be 42. If you don't know your times tables, you might need to check it. Okay, 6 times 2 is 12, plus another 4, 12, 13, 14, 15, 16. Carry 1. 6 times 4 is 24, plus 1 is 25. Carry 2. And 6 times 1 is 6, plus another 2 is 8. We have 1, 2, 3 decimal places, so 1, 2, 3 decimal places. So she will actually save in money £8 and 652, okay, in a year. How do I know it's a year? Because this was all using the year. Okay, now what she claims is that this is how much she will save a month. I want to know if that is actually matching what we have here. So 70p is the same as 0.7 in pounds. Okay, or you could do that later, doesn't matter. Okay, in fact we might do that later, and that is for 1 month, and so we're going to multiply that by 12 to find out in a year. So you might actually want to do it with this, and then we'll change it to pounds later. Okay, so at the moment let's skip that step and change it to pounds at the end, and at the moment let's just do our multiplying by 12. Okay, so we're going to multiply this one by 12, just because then we don't have any decimal points to worry about. 2 times 0 is 0, 2 times 7 is 14, 1 times 0 is 0, 1 times 7, we add these together, 0, 4, 8. So this is how many pence we have. So 840 pence is the same as £8.40. And the question is, she says, if I follow the advice, I will save more than this. So the question is, has she saved more? And you can see that this is more. And so the answer is yes, because she's actually saving that. Okay, excellent, well done. That's the end of that paper. I hope that's made some sense, and all the best. See you around. Bye.